In this video, I will explain about the implementing discrete time LTI system. Okay, you can refer to slide 26. Actually, the system is represented by the differential equation like this. Okay, yn plus a1 yn minus 1 plus a2 yn minus 2 equal to b0 xn plus b1 xn minus 1 plus b2 xn minus 2. So the second part is we need to take the z transform of different equation given. Okay, we change it to the z transform. Okay. This is the answer after you factorize. So I will explain to you. The first yn will be z plus the second term here is, we know that it is a1 z to the power of negative 1 because minus 1 here. So z plus a2 z minus 2 z equal to b0 xz because this is n plus 0. Okay. So no coefficient of z here. Okay, plus b1. Okay, this is minus 1, so you need to put z to the power of negative 1 xz plus b2 z to the power of negative 2 xz. Okay. So when you factorize this one, you will get like this. And when you factorize at the right sided differential equation, you will get like this. So from this differential equation, so we can find the transfer function hz equal to yz over xz. So you will get like this, y over x. Okay, so b0 plus b1 z minus 1 plus b2 z minus 2 over, okay, this part you bring it at the right side, it will be divided by 1 plus a1 z to the power of negative 1 plus a2 z to the power of negative 2. Okay, now I want to teach you how to draw this hz using block diagram. When you want to draw block diagram, I prefer you just refer to this differential equation that I wrote previously and start from input. Input is xz and the output is yz. Okay. So input, we know that the system input is xz and the output is yz. So what is hz here? So I want to teach you how to draw hz. The first one is refer to the input part, which is xz. You have b0 here, b0 xz, b0 multiply with xz. So we know that xz is input. So xz must multiply with b0. Okay. This is B naught. Xz will multiply with B naught. And then you see here, all of this is summation, addition. So this is the addition symbol. Okay, now we know that xz also will multiply with z to the power of negative 1, b1. So xz will multiply with z negative 1. Okay, xz multiply with z negative 1, b1. Okay, this is b1. Okay, xz multiply z to the power of negative 1 multiply with b1. So, okay, this is summation. The first term is add with the second terms here. This is the first term, this is the second terms. How about the third terms here? So, you need to xz multiply with z to the power of negative 1. Multiply again with z negative 1. Z negative 1 multiply with z negative 1 will be z negative 2. So, B2 is here. B2. So, xz multiply with z to the power of negative 1. Z to the power of negative 1 will be z to the power of negative 2, B2. You can see the third terms here. B2 times z to the power of negative 2 xz. So, all of these terms will be add. So, this is the summation. Okay. And then we assume that, we're not finished yet. We assume that this is the results of WZ. Not YZ, because YZ also have another coefficient here. Z minus 1, Z minus 2, A1, A2. You need to consider all of these things to put in your block diagram. Okay, now we have YZ part. Okay, this is YZ only. So YZ times 1. Okay, so we know that YZ is output. So the arrow like this. Okay, so this is also the summation. Okay, because all of this is summation sign. So the first one is 1 times YZ. So we consider it YZ times 1 here. And the second part is A1 Z to the power of negative 1. Okay, YZ times Z to the power of negative 1 times. Okay, I want to do a correction here. At this arrow, you need to put summation symbol. If you not put the summation symbol, it is considered as multiplication. Okay, so you will multiply this part with this part. So it is wrong. So you need to put summation here. So this one is from the second terms here. A1 Z to the power of negative 1. So YZ times Z to the power of negative 1. Negative A1. Okay, this is the summation part. Okay, why negative A1? Because of the arrow here. So this is the different arrow. This arrow show at the right side arrow. And this arrow is at the left side arrow. So you must change this one to negative A1. Okay, then the second part is A to Z to the power of negative 2. So it is like this, Z negative 1 B negative A2. Okay, so this is our block diagram. Okay, now we go to example 1. Okay, the question asks you to determine the transfer function and differential equation representation of the causal system described by the following difference equations. So we have this difference equation, which is yn equal to xn minus xn minus 2 plus xn minus 4 minus xn minus 6. So the first step is you need to find Z transform for each terms. So we know that yn, the Z transform is yz, xn, xz, minus z to the power of negative 2 xz, plus z to the power of negative 4 xz, minus z to the power of negative 6 xz. So you can factorize. It will be like this after you factorize. Okay. Now you can find hz. Okay, this is your hz. Don't forget, if you refer to Z transform pairs tables, this hz, you can change it to impulse response like this. Hn equal to impulse n equal to 1 minus impulse n minus 2 plus impulse n minus 4 minus impulse n minus 6. Okay. This is the answer for impulse response, and I will teach you how to draw the block diagram. So the first thing you need to refer to this Z transform expression, and then you need to start from left, which is start from input x z. We know that xz, the first is times 1, xz times 1. So we will do summation here. Okay, times 1. Okay, and the second terms is negative 1 times z to the power of negative 2. So we know that this is z negative 2 xz times z negative 2, and then times negative 1. Okay, don't forget the summation sign here. Okay, and then you have z to the power of negative 4. Okay, this is z negative 2. Okay, z negative 2 times z negative 2 is equal to z to the power of negative 4 times 1. Okay, this is 1. Okay, the last terms is minus z negative 6. So this is z negative 6. Okay, This is negative 1. So how about y? Okay. So you just put yz here. Okay, now we go to the example 2. The question asks you to find the transfer function hz of the discrete time system represented in the block diagram below. So you need to find what is the transfer function. Here is xn. You need to change it to xz. Okay. And here you can change it to yz. Okay. Now we know that this is the plus sign. Okay. We must assume that here we will get pz. Okay. So now we want to find pz. Pz equal to xz here plus xz. This is xz plus, okay, symbol plus, plus this loop. This loop is pz times z to the power of negative 1 times negative 1 over 2. So, negative 1 over 2 z negative 1 pz. So I will put pz to the left side. Okay, you will get pz. After you factorize, you will get pz 1 plus 1 over 2 z to the power of negative 1 equal to xz. And then we need to find this right-sided part. Yn is equal to yz is equal to pz plus yz times z to the power of negative 1 times 1 over 4 plus 1 over 4 z to the power of negative 1 times yz. Okay, now we can substitute pz, which is come from the previous equation. So here we have pz equal to xz over 1 plus 1 over 2 z to the power of negative 1. So we substitute in this pz here, xz over 1 plus 1 over 2 z to the power of negative 1 plus 1 over 4 z to the power of negative 1 yz. Now we have this equation. Okay, so I will put yz at the left side and then I will factorize equal to 1 over 1 plus 1 over 2 z to the power of negative 1 xz. So we need to find, the question asks you to find hz. Hz equal to output over input. So you will get the answer is 1 over 1 plus 1 over 2 z to the power of negative 1 over 1 minus 1 over 4 z to the power of negative 1. Okay. So 1 over 1 plus 1 over 2 z negative 1, 1 minus 1 over 4 z negative 1. Okay. This is the answer. Okay. Actually, from this answer, you can find the impulse response, you can find the stability, and also you can find the causality of this system. Okay, now we go to example 3. Okay. The question asks you to find the transfer function Hz of the discrete time LTI system represented in the block diagram below. Okay, this is the LTI system. Okay, so you need to find the Hz. How you can find the Hz? I believe that you feel it is difficult, but you can draw it again based on your understanding. Okay, first, okay, I will draw it again. Okay, so that you can understand more. Okay, this is xn. Okay. The summation symbol is here, plus. Okay, we know that we have Qn, but Qn, this is just the straight line actually. You can draw it as straight line. So you can find Qn here. Qn with arrow, like this. Okay, Qn, you will find it here. Okay, okay, this is the straight line. Okay, I will draw it again, straight line, with arrow here and arrow at the below. Okay, and then you will find another summation here. Okay, plus. Okay, now you have z to the power of -1. So here is z to the power of -1, and another arrow like this to the right and to the left. Okay. And you will find k over 2. Okay, to the right and to the left. Okay. K over 2, and then another arrow, which is until you find the summation here. This is another arrow. Okay, plus. Qn minus 1 is here. Okay, this is another symbol, plus. And Yn is here. Yn. Okay. So this both drawings is same actually. Okay, so I will put aside this one. Okay. How do you find the transfer function of this figure? Okay. Firstly, change this xn to xz. So this is xz. Okay. And then Qn with Qz. Okay. Yn with Yz. How about this one? This is z to the power of -1 Qz. Actually, it is come from here. Qz times z to the power of -1. So you will get z -1 Qz. Okay. Firstly, okay, you need to find Qz. Qz actually equal to xz. This is summation. You need to plus the whole loop here. Qz, sorry, k over 2. K over 2 times z to the power of -1 Qz. Okay. So this is the first equation. What about the second equation? The second part is you need to find yz. Yz is equal to this qz plus this part k over 2 z to the power of negative 1 q z. This is the second equation. From the first equation, bring qz to the left side and factorize the equation. Okay, the second part is yz equal to qz 1 plus k over 2 z to the power of negative 1. Okay, now substitute qz here into this equation. So from this qz, you will get 1 over 1 minus k over 2 z to the power negative 1 x z. Okay, so substitute this equation into yz. Okay, so you will have yz equal to 1 plus k over 2 z to the power of negative 1 over 1 minus k over 2 z to the power of negative 1 x z. So you can find transfer function hz equal to output over input equal to 1 plus k over 2 z to the power of negative 1 1 minus k over 2 z to the power of negative 1. Okay, this is your answer. Okay, that's all. Thank you.